Welcome back दोस्तों. In the previous section we talked about addition compounds which were classified into two types. One is double salts or mixed salts. So this was the first classification. We classified addition compounds, means compounds formed by addition of two or more substances, into two types. One is double salts or mixed salts, another is coordination complexes. The first classification, we took the example of carnallite. So carnallite is a double salt composed of KCl, potassium chloride, and magnesium chloride, MgCl2 dot 6 water of crystallization, 6H2O. This was one example for double salt, which is carnallite. Other than that, we saw another example which is potash alum, which is K2SO4 dot Al2SO4 thrice dot 24 water of crystallization. The role of water of crystallization is to crystallize that substance. When we mix two salts, K2SO4 and Al2SO4 thrice, then on crystallization, when the crystal structure is formed, the H2O molecules are interspaced in that crystal. If I heat this potash alum, what will happen? That this water of crystallization will evaporate. So when water of crystallization evaporates, we are left with anhydrous potash alum. So we will have anhydrous potash alum. So whenever we heat a double salt which has water of crystallization, what will happen? The crystal structure will be lost and we will be left with anhydrous salt. So for example, if we take this potash alum, so this is potash alum, and if I heat it, this is for now in crystal form because there is water of crystallization. In each mole of potash alum, there are 24 moles of H2O, water of crystallization. But when we heat this potash alum, we will get anhydrous potash alum. Similarly, if I heat this double salt, carnallite, so what will happen? The water of crystallization will evaporate and we will be left with anhydrous carnallite, anhydrous KCl dot MgCl2. So these are classification of addition compounds into double salts or mixed salt. Simple salt example we already took. Simple salt is just single salt like NaCl or KCl or Al2SO4 thrice or any of the single salt, that is simple salt. Double salt is a mixture of two salts like KCl dot MgCl2. With water of crystallization, it will form a crystalline substance, and on heating that crystalline double salt, we will get anhydrous salt. So this is about the classification of addition compounds into double salts. Now, what is the property of double salt? When I take this double salt, for example, potash alum, this is a double salt. We have two salts in it, K2SO4 and Al2SO4 thrice. So if I take this salt K2SO4 dot Al2SO4 thrice and 24 H2O. So if I take this salt and I make its aqueous solution, suppose if I put this potash alum in water, so what will happen? I will get the constituent ions like K2SO4 is composed of potassium K plus ions, 2 potassium ions and 1 sulfate ion. So we will have 2 potassium ions, 1 sulfate ion, then we will have 2 aluminium ions Al plus 3, 3 sulfate ions SO4 2 minus. So this will be the various constituents which I will get. Upon taking aqueous solution of a double salt, we get its constituent ions like potassium, sulfate, aluminium, sulfate, and so on. But Instead of this, if I take another salt, again let us say take carnallite. So KCl dot MgCl2 dot 6H2. So if I take the aqueous solution of this carnallite, what will I get? I will get the constituent ions like K plus, Cl minus, magnesium, Mg2 plus, 2 chloride ions, etc. So we will get the constituent ions on taking the aqueous solution of a double salt. So this is the concept. Now, if I do the confirmatory test, what is confirmatory test? Confirmatory test का मतलब है कि हम लोग उस आयन का टेस्ट करेंगे. कौन सा आयन? पोटेशियम आयन का टेस्ट करेंगे. तो it will give positive test for potassium ion. This salt carnallite will give positive test for potassium ion, for chloride ion, for magnesium ions, for chloride ions. So it will give a confirmatory test for its constituent ions. Similarly, potash alum will give confirmatory test for potassium ions, sulfate ions, aluminium ions, and so on. So this is the characteristic of double salt. When a double salt is having its aqueous solution, it will break down into its constituent ions, and we will get confirmatory test for each and every constituent ion. But for coordination compounds, we have a different concept. So let us see what is the difference between double salt and a coordination complex. So we also took the example of a coordination complex. For example, coordination compound, let us take the example of K4FeCN6. This is a coordination compound. Why? Because it has coordinate bond. What does it have? It has coordinate bond in it. So let us see the structure of this species which we have, K4FeCN6. So K4FeCN6, this is the compound. This is a coordination compound. In it we have two parts. One is the counter ion. This is called as counter ion. The thing outside the coordination sphere. This is a coordination sphere. So let us first familiarize ourselves with the terms. The species or the part inside the square brackets. You can see this is a square bracket. So the part inside the square bracket is called as coordination sphere. So FeCN6 in square bracket, and what will be the charge? 4 minus. Why will we have a 4 minus charge? Because on each potassium atom, or we can say on each K plus ion, we have potassium ions here. So on each ion we have +1 charge. There are 4 such ions. So on 4 ions we will have 4K plus. That means +4 charge. Each potassium ion +1 charge. 4 potassium ions +4 charge. So in K4FeCN6 we will have +4 charge on the counter ion, which is K4. First of all, the part inside the square bracket is called coordination sphere, and extra part is called as counter ion. The part other than the coordination sphere, we will call it counter ion, which balances the charge, because on this we have a charge of -4. On the counter ion we will have a charge of +4 to neutralize the entire compound. So this is a coordination compound. The first part here we call it counter ion, and the part inside the square bracket we denote as coordination sphere. Now the part inside this coordination sphere is the coordination complex. So this here in K4FeCN6 in square bracket we will have the FeCN6 4 minus. This is the coordination complex. So this is our coordination sphere, we can say, or coordination complex. In this we will have coordinate bonds between the metal atom, which is iron, and cyanide, which are giving off the coordinate bond. So cyanide Cn minus, they will give 1 electron pair each, to the central metal atom. Fe here is called as central metal atom. We call this Fe as central metal atom. The condition for a welcome back dosto. In the previous section we were discussing about addition or molecular compounds. So let me write the topic which we are discussing, addition or molecular compounds. So we had classified these addition and molecular compounds into two classifications. First classification for addition or molecular compounds was double salts, which are also called as mixed salts. Then after that we have the another classification which is coordination compounds. So these were the two classification of addition or molecular compounds. First we classify them into double salts or mixed salts, and another classification is coordination compounds. So what was the example of double salts? We took various examples, carnallite, potash alum. So let me write the formula. Potash alum, which is K2SO4.Al2SO4 thrice dot 24H2O. This is the molecular formula of potash alum, जो हम लोग फिटकनी यूज करते हैं दाढ़ी बनाने के लिए and in purification of water. So that is potash alum. Okay. So next we have the example of coordination compound which we took, K4FeCN6. This is an example of a coordination compound. Why do we call it coordination compound? Because it has coordinate bonds. What is a coordinate bond? So coordinate bond is a bond in which one atom shares both its electrons with other atom or group. So this is our example of coordination compound. इसका नाम क्या है? What is the name of this coordination compound? So let us try to name this compound. So name हम लोग आगे जाके पढ़ेंगे डिटेल में, but for now थोड़ा basic idea दे देता हूं मैं. जैसे अगर NaCl है, सोडियम क्लोराइड, this is our common salt. इसमें हम लोग क्या बोलते हैं? सोडियम. Why do we call sodium first? Because it is the cation part, and then we call chloride, which is the anion part. First we name cation, then we name anion. तो ऐसा ही हम लोग यहाँ पे भी करेंगे. First we will name cation, which is the potassium, and then we will name this group. Okay. So what will be the name of this salt? Cation, which is potassium. Okay. Now how do we name further? हम लोग ज़्यादा डिटेल में देखेंगे, but for now let me give you the name. Potassium is the cation, then we will name the anion. Who is the anion in this case? The anion in this case is this species, FeCN6 in square brackets with 4 minus charge. How do I know 4 minus charge? Because we have 4 potassium atoms. So potassium ion, one potassium ion has +1 charge, 4 potassium ions will have +4 charge. So this species is bound to have -4 charge because overall there is no charge on this K4FeCN6. So +4 on the cation, -4 on the anion. It is similar to +1 on the cation, which is sodium, and -1 on chlorine. So chlorine has -1 charge, chloride ion has -1 charge, sodium ion has +1 charge. That's why overall sodium chloride is neutral. So this is named as potassium, the cation first, then let us name this thing. So we have here 6 ligands. What do we have? 6 ligands. What is ligand? Ligand is electron pair donor. So we have 6 electron pair donors. Which is the species who is donating electrons? It is cyanide ions, Cn minus ions, which are poisonous. We know cyanide is poisonous. Okay, so Cn minus ions in this case are the ligands, which are electron pair donors. Whom are they donating electron pairs to? They are donating electron pairs to the ferrous ion, Fe+2. So we will see later on this has an oxidation state of +2. So ferrous ions is the one who is taking those ligands or the electron pairs from the ligands. So how many ligands we have? 6. Hence we will name this as potassium hexacyano. Cyanide, we call it as cyano in coordination compounds. Whenever we call ligand, we generally have the name O at the end. Potassium is the cation. Hexacyano, because there are 6 cyanide ions who are donating by coordinate bonds to the iron atom. And in this case, we have ferrate ion. What will we call? Ferrate ion. Ferrate. Why do we call it ferrate? Because we have iron atom. Iron we call ferrous, ferric. In this case, iron is in +2 oxidation state. So it is ferrous. So we'll write it as ferrate. Why did I write this suffix 8 here? Because whenever we have the anion, whenever we have this coordination complex, this square bracket as an anion, then in that case we will consider the central metal atom with the suffix 8 at the end. Finally, we will write the oxidation number of this Fe in Roman letters. So what is the oxidation state of Fe? It is +2. So in Roman letters I will write it 2. How do I know this has an oxidation state of +2? So let us try to find the oxidation state of Fe in this case. So we have the compound which is K4FeCN6. So let us try to find the oxidation state of Fe in it. So we know there are 4 potassium atoms. So we can say +4 charge, because potassium atom or the potassium ion has +1 charge. There are 4 potassium ions, so +4 charge. Plus we want to find the oxidation state of iron. Let us write it as Fe itself, because that is an unknown. So we have 6 cyanide ions. What is the charge on a cyanide ion? Cn minus, so it is -1 charge. On each cyanide ion we have a charge -1. So 6 cyanide ions will have a charge 6 into -1, which is -6. And that sum of all the oxidation states will be 0. Why? Because overall this compound is neutral. So from this equation we can easily get the oxidation state of iron as 4 plus Fe minus 6 is 0, giving us the Fe oxidation state as +2. Hence in parenthesis here we have written +2 oxidation state in Roman letter. तो ऐसा हम लोग का nomenclature होगा coordination compound का. Of course, this is very new to you. We will take many examples later on when we study the nomenclature of coordination compound in more detail. But for now, remember the basic rules. Initially we name the cation, then we name the anion. So cation, potassium, then we have this coordination sphere. What is coordination sphere? The species inside the square bracket, which is central atom and the ligands. Who is the central atom? It is central metal atom, in this case is iron, and ligands in this case the electron pair donors are the cyanide ions. The convention which we follow for ligands, will write O as the suffix. So hence I have written cyanide as cyano. We can also write it as cyanido. Okay, so I have written cyano for now. Then uske baad we find the oxidation state of the central metal atom. Oxidation state of iron is +2, so we'll write it in Roman letters. और ferrate क्यों लिख दिया यहाँ पे? Why do we have suffix 8 here? Because the anion, if the coordination sphere, or we can say the species under square bracket is an anion, means it has negative charge, and we have already seen it has negative charge. FeCN6 4 minus -4 negative charge. That means we will add the suffix 8 at the end. ऐसा हमारा थोड़ा सा rules है. We'll study in more detail later on. But for now, I have named this in the convention of IUPAC, which is potassium hexacyanoferrate bracket 2. So this is the name of the coordination compound. Now, why do we call this a coordination compound? ये भी हम लोग डिटेल में समझने का कोशिश करते हैं. Because as you know, coordination compounds are those compounds in which we have coordinate bonds. So coordinate bond मतलब क्या? As I told you, the bond in which one of the atoms shares both its electrons, or one electron pair or more than one electron pair, that will be classified as a coordination compound. So let us take the example of this FeCN6 4-. Why do we classify it as a coordination compound? So our coordination compound in this case is K4FeCN6, and in it the part which has coordinate bond is this part, FeCN6 raised to 4-, -4 charge on this species. So why it is a coordination compound. For that, let us understand in more detail. So if you remember 11th standard, you have studied atomic structure. There we have Aufbau principle. So in 11th standard we studied Aufbau principle, which is used to find the electronic configuration of any atom or ion. So let us try to find the electronic configuration of iron atom. Iron has atomic number 26. So let us write the electronic configuration for iron. It will be 1s2, 2s2, then we will have 2p6, then 3s2, then 3p6, then 4s2, then 3d6. How do I know this will be the electronic configuration? Because iron has atomic number 26, so if you calculate, in all we have 26 electrons. So let us start the calculation. 2 electrons in 1s orbital, 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, 18 plus 2, 20, 20 plus 6, 26. So indeed we have 26 electrons in this case distributed in various s, p and d orbitals. So after this, let us find the electronic configuration for ferrous iron, Fe plus 2. Why? Because we have already found the oxidation number of iron in this compound is plus 2. So when we want to find the oxidation number of this iron, it is plus 2, which is ferrous. So we will have to remove 2 electrons from iron atom. To go from Fe, which has 26 electrons, to Fe plus 2, we will have to remove 2 electrons and we will be left with 24 electrons. So in this case, how will I write the Fe plus 2 structure? So from the outermost orbit, which is the 4s orbit, we will remove 2 electrons. So let us remove these 2 electrons. So how will the configuration look like? It will be 1s2, so 2 electrons in 1s orbital, followed by 2s2, which is 2 electrons in 2s orbital. Then we will have 2p6, 1, 2, 3, 4, 5, 6 electrons in 2p6 orbital. Then we have 3s orbital. In 3s orbital I have 2 electrons followed by 3p6. In 3p orbital we have 6 electrons, which gives it 3p6. Then we have our 4s and 3d orbital. So let us say if I draw 3d orbital. So 3d, d orbital has 5 in all. We have in 3d we have 5 orbitals: dxy, dyz, dzx, dx square minus y square, dz square. So in it we have 6 electrons: 1, 2, 3, 4, 5, and finally 6. Other than this, we have 4s2, which I have drawn here. This is 4s2. This is 3d6. So this is how we have the electronic configuration for ferrous iron. This is ferrous iron, which is making a coordination compound. Okay. Now, which of these will write first? Will we write 4s first or 3d first? 4s has more energy because it is corresponding to principal quantum number 4. Whereas 3d is corresponding to principal quantum number 3. So let me write 4s on this side. So this is our 4s2. Okay. So this is how we'll write the electronic configuration for ferrous iron, Fe plus 2. Now, in this case, we have to remove 2 electrons. Initially, we had Fe, which has 26 electrons, ferrous, which has 24 electrons. So of which orbital will I remove 2 electrons? Of course, from the outermost orbit, which is 4s orbit. So let me remove this 2 electrons from the outermost orbit. So in this case, this is the structure for ferrous iron. 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2 is empty. So this is our orbital. This is our electronic configuration for ferrous iron. Now, let us see this compound in more detail. FeCN6. Okay. So we have Fe, which is the central metal atom, which is in +2 oxidation state. Now it has to accept electrons from cyanide ions. How many cyanide ions we have? We have 6 cyanide ions. So each of these cyanide ions is donating a pair of electron. It is sharing a pair of electron. Each cyanide ion will share 2 electrons. So this cyanide ion shares 2 electrons. This cyanide ion shares 2 electrons. Similar is the case with every cyanide ion. So overall, how many electrons does Fe+2 have to accept? कितने इलेक्ट्रॉन्स Fe+2 एक्सेप्ट करेगा? हर एक दो 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 देंगे तो दो दो 6 बार मींस 12 इलेक्ट्रॉन्स एक्सेप्ट करने. द Fe+2 ion, it has to accept 12 electrons. That means 6 electron pairs, which is 12 single electrons. तो इतने इलेक्ट्रॉन पेयर उसको एक्सेप्ट करने हैं. तो इतने इलेक्ट्रॉन पेयर एक्सेप्ट करने के लिए इसका हाइब्रिडाइजेशन होगा. नाउ देयर विल बी हाइब्रिडाइजेशन which we have studied in 11th standard chemical bonding. केमिकल बॉन्डिंग में हमने हाइब्रिडाइजेशन कॉन्सेप्ट सुना है. So 4s के बाद हमारे पास क्या होगा? 4s के बाद we have 4p orbitals. 4p orbitals होंगे. तो let me show the hybridization. Hybridization कैसा आएगा? Ferrous in this case will undergo D2sp3 hybridization. मुझे कैसे समझेगा D2sp3 hybridization होगा? Because it has to accept 12 electrons. That means 6 electron pairs. देखते हैं हम लोग कैसे होगा. तो देखो हम लोग पहले ये आर्गॉन का स्ट्रक्चर है कि नहीं, यहां से यहां तक तो हमारे पास आर्गॉन का ही स्ट्रक्चर है. 2 + 2 4, 4 + 6 10, 10 + 2 12, 12 + 6 18. तो दिस इज आर्गॉन स्ट्रक्चर. ये आर्गॉन का इलेक्ट्रॉनिक कॉन्फ़िगरेशन है. तो शॉर्ट हैंड नोटेशन यूज कर रहा है. शॉर्ट हैंड नोटेशन में हमारे पास क्या है? फेरस आयन का कॉन्फ़िगरेशन है आर्गॉन इलेक्ट्रॉनिक कॉन्फ़िगरेशन फॉलोड बाय 3d6. वी हैव 3d6 in which we have overall 6 electrons. 1 2 3 4 5 and finally 6. Okay. फिर उसके बाद हमारे पास 4s ऑर्बिटल अब खाली है. 4s ऑर्बिटल इज एम्प्टी. उसके बाद हमारे पास p ऑर्बिटल भी होंगे. 4p ऑर्बिटल इज आल्सो एम्प्टी. तो देखो अब क्या होगा ये हम लोग को समझना है. Now in this case what will happen? It will undergo D2sp3 hybridization. मुझे कैसे समझेगा D2sp3 hybridization होगा? तो उसके लिए पहले 11th स्टैंडर्ड का केमिकल बॉन्डिंग हमें अच्छे से आना चाहिए. 11th स्टैंडर्ड में आई हैव एक्सप्लेन्ड केमिकल बॉन्डिंग. केमिकल बॉन्डिंग का लेक्चर देखो, उसके बाद हाइब्रिडाइजेशन टॉपिक विल बिकम मोर इजी. ओके, सो लेट अस सी द D2sp3 hybridization of Fe+2 to form this compound K4FeCl6. तो देखो अब क्या होगा, हमारे पास साइनाइड आयंस है. व्हाट आर वी हैव? साइनाइड इज द लिगेंड. ये कौन है? लिगेंड. लिगेंड मतलब इलेक्ट्रॉन पेयर डोनर. अब ये जो लिगेंड होता है, दिस इज अ स्ट्रॉन्ग लिगेंड. साइनाइड इज अ स्ट्रॉन्ग लिगेंड. ओके, तो स्ट्रॉन्ग लिगेंड है तो मतलब उसका इलेक्ट्रॉन्स का जो रिपल्शन है वो ज्यादा होगा. साइनाइड इज अ स्ट्रॉन्ग लिगेंड and there will be lots and lots of repulsion of electrons because it is already negative. नेगेटिव है तो वो इलेक्ट्रॉन्स को रिपेल करेगा. तो यहाँ पे देख रहे हैं हम लोग 1 2 3 4 4 इलेक्ट्रॉन्स पड़े हैं कि नहीं अकेले अकेले. तो 4 इलेक्ट्रॉन्स जो अकेले थे, अब क्या होगा? पेयरिंग स्टार्ट होगा. ड्यू टू द रिपल्शन व्हेन साइनाइड आयन attacks this central metal atom, there will be repulsion, and due to the repulsion this electron which is there in this 3d orbital will start pairing up. तो यहाँ पे pairing हो जाएगा. क्या हो जाएगा? Pairing. Okay, repulsion के कारण cyanide strong ligand, it is electrons, they will repel these 3d electrons and these 3d electrons will start pairing up. Pairing होने के बाद हमारा स्ट्रक्चर कैसा हो जाएगा? On hybridization of this Fe+2, the central metal atom, we have the electronic configuration which is argon, which is followed by the 3d orbital in which pairing has taken place. तो यहाँ पे pairing होना चालू हो जाएगा. तो it is like this. This is the new structure of 3d orbital, 3d6, and 4s remains empty itself and 4p remains empty itself. 4p तो खाली ही पहले से. Okay, ऐसा ये स्ट्रक्चर बन जाएगा Fe+2. दिस इज आफ्टर हाइब्रिडाइजेशन. हाइब्रिडाइजेशन होने के बाद ऐसा स्ट्रक्चर बनेगा. अब देखो मुझे कैसे आइडिया आएगा कि ऐसा हो रहा है? बिकॉज एज आई टोल्ड यू, वी हैव दिस कंपाउंड व्हिच इज एग्जिस्टिंग इन नेचर. K4FeCl6 नेचर में अच्छा खासा स्टेबल स्ट्रक्चर है. तो हमें पता है कि ऐसा कंपाउंड बन रहा है. और ऐसा कंपाउंड कब बनेगा? जब हम लोग 6 साइनाइड आयंस, ये 6 साइनाइड आयंस, हर एक साइनाइड आयन इलेक्ट्रॉन पेयर डोनेट करेगा. डोनेट मतलब शेयर करेगा बाय कोऑर्डिनेट बॉन्ड. तो एक साइनाइड 2 इलेक्ट्रॉन दे रहा है तो 6 साइनाइड 12 इलेक्ट्रॉन देंगे तो 12 इलेक्ट्रॉन का जगह बनना चाहिए। तो ये देखो ये रहा 12 इलेक्ट्रॉन का जगह। इफ यू सी केयरफुली देखो कितने ऑर्बिटल्स हैं 1 2 3 4 5 6। So we have 6 vacant orbitals, and in 6 vacant orbitals we can have 12 electrons which will come from cyanide ions and they will hybridize. ये सब एक साथ मिल जाएंगे। Let me show the structure after hybridization. So it will be like this. How many orbitals will be there? 6 orbitals. 1 2 3 4 5 6. All these orbitals are D2sp3 hybrid orbitals. D2sp3 क्यों बोला है? क्योंकि यहाँ पे इनर शेल d ऑर्बिटल्स हाइब्रिडाइजेशन में पार्टिसिपेट कर रहे हैं, 3d के ऑर्बिटल्स पार्टिसिपेट कर रहे हैं और बाहर वाले फोरेस के ऑर्बिटल्स पार्टिसिपेट कर रहे हैं। तो इसीलिए हम लोग ने d को पहले लिखा है, पहले 2 d ऑर्बिटल, फिर एक s ऑर्बिटल, फिर 3 p ऑर्बिटल। D2sp3 हाइब्रिडाइजेशन हो जाएगा। अब D2sp3 हाइब्रिडाइजेशन होने के बाद कितने ऑर्बिटल्स बनेंगे? We will have 6 D2sp3 हाइब्रिड ऑर्बिटल्स। So 6 D2sp3 हाइब्रिड ऑर्बिटल्स बन गए। अब इनमें क्या आएंगे? तो इनमें